Okay, so let's first talk about the capillary action. I will use experiment on capillary action or capillaries in capillary tube by Science Sir. You can find it on YouTube. Find it and like it if you can. So let's watch it for a moment. Later I will get to Jamboard to explain something. Yes, so you can see that those tubes are extremely tiny. Yes. Yeah, here's just showing that it is really tiny lumen of these vessels. Yeah, but you already know something about cohesion and adhesion. Exactly. So thanks to adhesion, the water keeps to the bud. It's important just that this is colorful. It's not important what exactly there is. It's only important that there is a color attached to show us what would happen with the fluid inside of these capillaries, of these glass capillaries. And you can see the magic. Yes, so the fluid is rising, and the force that is pushing it up is the adhesion. Yes, this shows us what is the capillary action. And now we are getting the capillaries with decreasing diameter. Exactly, so it flows up. You see that the thinner the capillary, the higher the fluid gets. So it suggests that the adhesive forces gets stronger relative to the gravity in case of the thinner capillaries. And you can see how fast it was, yes? And how far higher it is in case of the thinnest capillary. So yeah, the thinner the tube, the higher it would get. So this is very important concept. Okay, so now let's get to the Jamboard. So, how does the capillary action happens? Generally, imagine one more time this situation from the experiment. So we have the capillary and some fluid below. You know that the walls of the capillaries and the water are attracted to each other. So there are adhesive forces between those two. So you can imagine that these water particles that are here want to glue them as close as possible to the glass inside. So what is happening? There is some contest between those particles. So imagine that we get, let's make it bigger, yes? So we'll make bigger this part. Yes. And there is water here. So let's make there is some kind of contest between those water particles. So let's imagine that we are here. Yes. Those water particles are already above the level of water because they want to attach to the glass. And there is no free spot below. So when those molecules below want to attach to the glass, they need to go even higher. And higher and higher and higher and higher and higher. And this is how it goes through the capillary. Of course, the bigger the mass of the water here, the faster this process would stop. Because sooner or later the gravity would stop the rise, yes? When the force of the gravity, when the mass of this water here would be too high to sustain, this would just drop. So it rises until the force of gravity is not strong enough to get it down. So the smaller the mass of the fluid here, the higher it can get. And that's why the light of these capillaries is so critically important, because the bigger the capillary, the more of the water would be in the middle here, and the bigger the mass. So in this case, when we have a very thin capillary, the mass inside is very small, so it can rise high. When the capillary is thick, the mass is big, the surface is relatively small because the surface is increasing far slower than the volume, and it leads to the situation that the capillary action is happening only in the small capillaries, and it would not be visible, at least in case of the big pipes. Okay, and the surface tension. What is surface tension? Generally, one more time, this is a fluid, some water for example, and as you know, if you would put a needle on the water generally, like in the old compasses, this needle would stay on the surface of the water. How is it possible? You know from the Archimedes that generally everything that has a higher density than waters should sink. And the needle is made of steel, so it should sink theoretically, but it's not. It's not sinking down because of the surface tension. So surface tension is some force that keeps the objects on the surface. So how to understand the surface tension? So now let's look from the top at the water particles. Yes, they are close to each other, and there is a cohesive forces between these particles. So all of those particles attaches to each other. But you may think about the very peculiar thing, because as you know, getting back to the needle, if you would put the needle into the water, if you would break the surface, the needle would sink to the bottom. Yes? But why? If we know that the particles of water are attracting everywhere, they are attracting themselves also inside the fluid. So what is different between inside of the fluid and the surface? Because we are talking about surface tension, so we need to think what is so special about surface. And there is an answer. So now let's get from the side. Yes, this is the surface here above. This is the surface. And here we have these water particles. So, or maybe let's make only couple water particles to make it clear. Yes, there is a surface. Okay, there is such situation. And you must imagine that from all sides there are water particles. So now let's analyze this water particle. It's attracted up to the sides, down, into every direction. Yes? So it's attracted into every direction. As you know, when we have two vectors of the same strength that are on the same line, but they have different directions, they cancel up. So this vector will cancel out this vector. This vector would cancel up with this vector. This one with this one. And this one with this. There is no... Generally, I had not drawn it, but this one would be cancelled with this one. Yes? So, one more time, because I suppose it may be hard. So we have forces attracting to the particles above, below, to the one side and to the other side, yes? And this vector will cancel this vector. This vector would cancel this vector, and so on. Of course, we have also oblique vectors and so on, but all of them would cancel up because we have the adhesive forces from all of the sides. So the net force is zero. That's why we do not have any surface tension inside the fluid. But what is happening for this particle? We have some forces down to the sides, and you can imagine that this on the very surface would cancel up, but those forces would not. Yes, because we have nothing above. There is no cohesive forces from above. So those particles near the surface would be kept with the rest of the fluid. They would not want to untouch from them, yes, because there is a force that is keeping them together. So the net force is non-zero, and this is a surface tension. Okay, I hope that you understand. If not, of course, you can ask more questions on the classroom. So thank you very much.